the morning session where you hear lots of interesting talks, a lot of them are focusing on positioning, mapping, navigation. So I guess that's a sort of a common topic that in all the panelists. I guess we can start from that question. Do you think SLAM is solving the right problem for construction? Especially considering in the indoor case, the counterparts where we embodied AI for indoor service robots, is SLAM solving the right problem for construction? No matter whether yes or no, what do you think is the right way moving forward? What are some valuable research questions for the participants to think about? If you're ready, you can use that mic to.
Want to go first, Michael?
Sorry?
You want to go first?
Because I was the most outspoken. Do you want us to just take the mic?
Yeah, I think so.
Look, because we have very limited time and to give everyone a chance to speak, I'll just get us started. So I think there's two different aspects, right? One is you have to use the state-of-the-art tools that have been already subsidized by billions of dollars of investment from other major industries, like autonomous vehicles, like augmented reality, and other areas where a lot of the state-of-the-art SLAM technology has been motivated originally. So I think that's part of the reason we're trying to adapt these technologies to work in other domains like construction. In terms of your actual question, the flippant answer is of course not. The ultimate purpose of any mapping, positioning, and navigation system is not to exist for its own sake. It's to enable the higher level tasks you need to get done. And you can make a bunch of compelling arguments that current systems, A, don't work out of the box because it's very challenging, and B, are not bespoke enough to really suit the specific domain-specific purposes you want out of them. In a construction context, you can use them, but they're not optimized for that.
Just kind of adding on to the point that Michael was making. My thought process is probably, from an academic perspective for young students. So think about where that algorithm technology originated and what was the use case when it originated. This is about getting mobile robots around. And then suddenly you take that same technology and you throw it at 6 dozen problems, which it has got no relationship to. It's like I'm going to do A to build a map. If the objective is to build a very, very accurate map, then maybe SLAM is not your way to go. You could use good old multi-view geometry, structured motion techniques without having to solve the localization problem. So try to start with what is the problem you're trying to solve, rather than here's a broad brush that I try to use to solve everything. And by that, SLAM is nowhere close. And look at what industry has done. There are big LiDAR companies that have solved this problem very efficiently with their hardware. So,
So I think just to add to the point, one thing to keep in mind, we look at all those robots used indoors, like in homes, Roomba, Astro, Amazon coming up. We see all this autonomous driving on nice clean roads. Construction sites are fundamentally very messy places. You saw all the images of dust, and I know the one you were showing. So a lot of robotics technology we've seen in ICRA for the last 30 years, but when you go to construction sites, it's a very different domain and lots of challenges, lots of dust, and lots of unfriendly situations. So what academics have tested in a typical lab or indoor setting is a different setting with a different problem. So things just don't generalize very easily. That's what just keep in mind.
Any other panelists have a different point of view?
Actually, there are a lot of different areas of the construction. For me, especially, I am interested in the monitoring and inspection. For other guys, they are interested in real construction. So for inspection or monitoring, I think it is already prepared. We are already prepared for SLAM and navigation, but for the real construction, it's very hard for the sensory problem and other algorithmic problem. So depending on the situation, what you are situated in, there may be some gaps or some challenges, but for the inspection, I think we have reached a certain level.
Any other, I guess, yeah, if you have questions.
I was thinking about these.
I think it was, yeah.
proposition you were talking about earlier, figure out what kinds of constructions you might want to apply automation to. So would it be better to go for large constructions like hospitals, stadiums, or convention centers? Small numbers of big projects, or would it be better to go for lots of little projects, say like single-family homes, duplexes, schools, that sort of thing?
So you asked a question which is probably the primary question everybody in construction robotics, or at least on the industry side, is thinking about what is the value proposition where it goes. At least our experience has been the single family, those are not asset classes that are large enough for people to care about automation. They don't even care about the accuracy in those settings. It's the large asset classes like, at least $20 million and above. Now, even there's a massive fragmentation of the segment. There's real estate, there's infrastructure, there's manufacturing plants, and everything is its own beast. If I were to define it in an ML context, every segment is an auto distribution event. So you really have to pick something to specialize in. And this is where I think we kind of lose context as we say, oh, is X useful in construction and Y useful in construction? It's the same way as saying, is X useful in transport? What kind of transport are you talking about? Aerial, underwater, on land? Like the same way, construction is very complex and it's very broad. So it would be useful to kind of focus it down. And there are particular classes where there is a fair amount of repeatability. And there are classes where there is literally no repeatability. Like if you take large infrastructure, you don't have two stadiums that look exactly the same. Even the repeatable ones, two office buildings don't look exactly the same, though it's built by the exact same person. So you have to focus on where the value is. And at least for our assessment, because again, take a step outside of on-site construction and look at the whole field. If you're thinking about 2x2 family houses, that's probably moving in the direction of prefabrication, then trying to do things in automation on site.
Yeah, I would echo the same. Our robots, we mainly deploy them in the energy sector. So renewables is probably 80% of our business. Wind farms, solar farms. And I think the thing that's cool about those is that those projects are just massive sort of fractals, basically. Every little block in a solar farm looks like every other, just kind of scales up. And the contractors, they are really focused on efficiency in a way that you're not going to see on a single family home project, at least on that. So yeah, we very much focus on those kind of bigger projects.
So, guys, this is about the scope of multi-robot system and inspection. So, what are your thoughts on the idea of cooperative manipulation? Is there a need for that in actual construction for building a structure and things like that?
So is the question about collaboration between robots or collaboration between people and robots?
Collaboration between robots.
So I think that is in the future for sure. And we've done some experimentation with having like a bulldozer and an excavator work together, for example. I think, dump trucks and excavators are another thing the Baidu group has worked on. For now, though, we've found that it's kind of the most practical commercially to just have the robots work more or less by themselves, but in close collaboration with the people on the job site. And I think that just given the stage of the industry, construction robotics is a nascent field commercially. I think that's probably going to be what we're going to see for the next 5 to 10 years, in my estimation. And then from there, you'll start to see enough penetration of robots on job sites. Then you'll start to see these robots collaborate, and you'll see robots from different manufacturers, different groups work together. And I think that'll be the future. If we look, 20 or 30 years down the road.
Can I ask a question to the rest of
Of course.
So I have a question I hope is of general interest. So if you look at the last 5 years of investment in robotics tech, I'm sure some of the industry people here are screaming because you see the amount of money being invested in areas like on-road autonomous vehicles, where at the moment they're nowhere close to actually being remotely a going economic concern, right? And yet you have much higher constraints on you of probably showing economic viability in a short to medium time frame. What do you think of that? Does it frustrate you? Why do you think it's so much more grounded in construction, say, than in these other much more hyped up fields?
Maybe I'll let Noah take that and I'll kind of give my thoughts. He closed this round of context, so.
Yeah, so I think it's a very good question. I'm actually not sad about it though. I think what we're all working on here together it's huge. You know, this is going to shape the world in the future, and it's kind of nice that there's not 100 other people trying to do what we're trying to do. And maybe speaking a little bit selfishly. But I think that, you know, the reason for why investors are so excited about on-road autonomy, I think it's because every VC knows how to drive a car and none of them know how to operate an excavator. And so everybody kind of invests based on their personal experience, their personal biases. So I think that's got a lot to do with it. Yeah.
I have probably a slightly different take. Is I think this takes a little bit about understanding how VCs work, which is they're in to get a return on their investment within 5 to 10 years. And if this investment is not going to see the day of light, then you just need someone else to buy out your investment. So obviously, if I've hyped something and it hasn't made it, then I'm going to tell you it's amazing so that you can throw your money at this problem too, so that I can take my money out. There's a little bit of understanding the economics of why hype works. It's because someone is throwing money at the problem, someone is getting a return on investment. And most investment funds work with a 5 to 10 year cycle of trying to get their money out. So obviously, if you see that the technology hasn't matured, then you've lost all your money. So you go, all right, especially when you have a big bet going through, then you probably want someone else to jump into that same investment so that you can get your money out and keep doing this till, you know, you have an economic bubble that crashes, which is coming or has already started happening. I think the Nasdaq was down 20% or something like that. So it's coming and a lot of funding is going to get cut, which may be interesting to see what survives. Maybe the serious ideas that actually have impact. And construction, like Noah was mentioning, is ripe for impact. But somehow, you know, the hype is just getting there. But rather than hype, the problem is it's not like AV where you need to do X and then you can generate all the hype. And then the last 5% and it never commercializes. In construction, it's just off the gate, it's very hard. So only the serious players stick around and the hype just dies out.
So I'm an academic, I don't know much about VC funding, but the two things I should mention, one is of course there's a shortage of skilled labor, as mentioned. But let's think of, I work in autonomous driving, and one of the biggest on autonomous driving is when autonomous car has to operate next to human drivers. Humans are most unpredictable, not about environment talk. That's what makes autonomous driving too hard. With construction, fundamentally, you know, when you do a construction, even your road construction, you isolate the location. So reason we could build this, you know, excavators and do things, because the setting in which we operate is slightly more robot friendly. If you have a lot of humans next to the construction with the autonomous excavators, I'll be more nervous because, you know, we talk about perception, we talk about planning, they come a long way, they're nowhere solved, they can't get 100% reliability. So also to see your technology is partially working, it's not totally 100% robust. Can you isolate the problem condition where it can be applicable? And in construction, there are plenty of scenarios where we have such situation as opposed to driving on highways. So that's also made construction much more amenable for autonomous driving, autonomous robotics technologies.
Thanks a lot. Oh, okay. Maybe one more very quick question.
Yeah,
Sorry. Sorry. Yeah.
My question is around the terrain traversability compensation. So I think as we've discussed in the morning as well, the environment is super unstructured and messy, but at the same time, the material itself could be drivable or not drivable. So like, what are your thoughts on how should we go about this problem? Because if the autonomous robot has to move, the terrain has to be detected perfectly.
It's a very good question, and it's definitely a difficult perception problem. I've even tracked an excavator on solid ground once, so the problem is that I couldn't see any difference at all myself. So whether it's, you know, sufficiently compacted or just soft and people just sink into it, you just can't in the worst case capture that with any ordinary sensor. One thing you can do maybe is to do some cheating. So for example, you might know where the robots have been digging earlier and stuff like that. So, a very simple case, when we're digging a trench, what's in front of the robot is already dug, and obviously we restore that information. So that is one way to go about it. And the second one is of course perception.
Yeah, so that's a great question. And as you know, in fact, what we did was actually right now we were using visual sensors, LiDARs and cameras. And we built a database, like we showed you how many materials we had, but that's only visual sensor. Your visual sensor has limitations. Like even if suppose it rains today, right now, it's a big rain and it's a muddy, you look at the place and what you will do is you take a small step and get a feel of how slippery the surface is. And then you will walk fast. You just don't rely 100% on your visual itself. And so that's where we are. And I think the point is well taken. We would need some kind of force feedback sensing, which these excavators need, just like everything else. Vision has a limit. We come a long way, but we would need force feedback eventually to deal with that problem. You take a small step or something. There has been a lot of recent work in vision also. People are getting much better estimating material properties from visual and other inputs. So that's where good deep learning comes so good, that the visual sensor give you the force feedback. There's one line of research, or we come up with better sensors. So I think both will make good progress there.
Maybe from a more on the site, again, lots of fragments to construction, whether it's mining, excavation, what you're doing on site. Also probably some a leaf to take from other sectors rather than thinking about it as a purely construction problem and everything has to be self-contained with the robot. Something we can steal from logistics is there's already a lot of stuff on the shop floor. The same way, there's already a lot of stuff on the construction site. Use the other sensors that are there, use the other information that is there. There are surveyors, there are people sensing material densities. They have maps, very accurate maps, because that's where they're building. So use all that information. You don't have to, I think it's a more philosophical discussion on self-reliance versus relying on your neighbors and trying to get ahead in life. So I think there's this whole that we need to be able to accomplish everything by ourselves versus use your environment, try to see what other modes of modalities of sensing are available, what other information is available, and then try to leverage it and probably build a more robust solution than trying to put everything on the robot and expecting it to just magically work.
You can look at the other domains and not necessarily learn what to do, but you can definitely learn what you can't do. So we work in terrain traversability in defense, for example, and that's the all-on-board solution where you don't know the environment ahead of time. And we could name a half dozen pathologically unsolvable terrain traversability problems, which no one is close to solving. And so that gives you basically evidence that you want to cheat outrageously wherever possible in the construction domain.